In this lesson, we're going to take a look at putting it all together. We've already reviewed descriptive statistics and have taken a look at how to do some basic data visualizations. Here I am going to bring a lot of these concepts together to perform some data analysis. We'll start with a data set and some questions that arise from the data. Then we'll try to answer those questions in R. Lastly, we'll put our results together in an R Markdown document. Pay attention to the process here. It's similar to what you'll be asked to do in your first project. In a study, the biological gender, temperature in Fahrenheit, and the heart rate were recorded for 553 people. After looking at the data, there are several questions that we're going to address. What is the overall shape of the temperature data? Is the mean temperature close to 98.6, the temperature we expect? Is there a significant difference between temperatures for people born male and people born female? What about heart rates? Describe the differences in the shapes of distributions of heart rates for males versus females. At what value should we consider a person's temperature to be abnormal? Is it different for males and females? Does there appear to be a relationship between heart rate and temperature? We start by reading in the data. We call the data set TH, which stands for temps and heart rate. Here we see the data set and the three variables. Now I am going to install a new package named dplyr. This package makes data manipulation easier in R. In particular, from this package, we will use a filter command so that we can filter the data between male and female subjects. To install the package, run the install.packages command with dplyr as the argument. This only needs to be run once. I'm not going to run it here because it's already installed on my system. Once the package is installed, we can load it with the library command. Next, we are going to filter the male subjects into a new data set. We have the filter command, and the first argument is the original data set, TH. The second argument is the condition. Here we want all instances where the biogender variable equals male. This command creates a new data set named MTH. Similarly, we can create a new data set named FTH for female subjects. Let's take a look at MTH. We can see that it only contains male subjects, as expected. And similarly, FTH contains only female subjects. Okay, so now at this point we would normally attach our dataset to our workspace so we can access the variables directly. But we've got an issue here. I've got three different datasets that all contain the same three variables. So I'm going to take a different approach. I can call the variables I need directly using the following format: dataset name $variable. For example, say we want to find the mean of the heart rate data for male subjects. We enter the mean command, then MTH followed by a $, and then heart.rate as the variable. Okay, I think we're ready to tackle our first question. What is the overall shape of the data? To start with, I'm going to take a look at a histogram. We're talking about the overall data set here, so we're using th$body.temp. Notice that I'm also including titles here for the main graph and the X and Y labels. Overall, the temperatures appear to be approximately symmetric. They're also bell-shaped, also called normal. Let's confirm this with a box plot. In our box plot, we see that there is some skewness, but it doesn't appear to be very great. Temperatures appear more symmetric than skewed. Okay, so we've all heard that the normal body temperature is 98.6 degrees Fahrenheit, or 37 degrees Celsius. So in this study, is the mean temperature close to 98.6 degrees? Well, here we find the mean to be approximately 98.25 degrees, which is somewhat lower than 98.6. So a follow-up question is there a significant difference between temperatures for people born male and people born female? Once we answer that question for temperatures, we'll answer it for heart rates. We run the mean mth $body.temp command for the male temperatures, and a similar command for the female temperatures. What we find is that the mean male temperature is about 98.1, and the mean female temperature is about 98.4. It appears that female body temperatures are slightly higher on average. Let's repeat these calculations for heart rates. The average male heart rate is approximately 75.2 and the average female heart rate is 76.3. Again, it appears that female heart rates are slightly higher. Let's take a look at the differences in the shapes of the distributions of heart rates for males versus females. Here, we look at a histogram of male heart rates. It appears that male heart rates are mostly symmetric and bell-shaped. Now, a histogram for female heart rates. It appears that the data are slightly skewed to the left. I'm going to confirm this with a box plot. We can see that there are outliers that only appear on the left, again confirming skewness in that direction. At what value should we consider a person's temperature to be abnormal? Is it different for males and females? Well, we'll start by deciding on a cutoff point for what we'll consider unusual. Now, later in the semester, we'll look at more structured ways of doing this. But for now, let's say that anything that's beyond 3 standard deviations away from the mean is a reasonable cutoff point. I'm going to start by finding the mean of all body temperatures. Then I'll find the standard deviation. Now let's compute the temperature that is 3 standard deviations above the mean. We do this by adding 3 times the standard deviation to the mean. We find that our cutoff for what we consider to be abnormal is any temperature beyond 100.55. Now we do the same thing for male temperatures. We'll call the male mean temperature elm.mean and the standard deviation elm.sd. We compute the temperature that is 3 standard deviations above the mean. Here we find it as 100.22. Any male temperature beyond 100.22 we'll consider it to be abnormal. Lastly, we perform the same calculations for female temperatures. Here we find that any female temperature beyond 100.78 is considered abnormal. One thing I'll note here is that the differences are not very great for male and female cutoff values. And on to our last question. Does there appear to be a relationship between heart rate and temperature? Well, to answer this, we can take a look at a scatterplot of overall temperatures and heart rates. It appears that there may be a slight positive association between temperatures and heart rates. Let's find the correlation coefficient. The positive linear association between body temperature and heart rate is somewhat weak. A correlation coefficient of 0.267 confirms this. Now that we have gone through our initial analysis with our data, let's pull this into an R Markdown document for easy presentation. I'm going to select everything that's in my script file and copy it. Next, I'll open a new R Markdown document and give it a title. I will call mine Temperature and Heart Rate Comparison by Gender. After selecting OK, my document appears. Now is probably a good time to go ahead and save it. It will also be a good idea to save your document periodically as you're working on it. Alright, I'm going to erase everything that appears below the initial parameters and then paste my script in. Now we need to do a good bit of cleaning up. Mainly, I will concentrate on putting in appropriate headers. I also need to make sure that I have all R commands in R code chunks. Lastly, I'll put in place appropriate formatting for any comments that may be needed to explain the results. Now, we talked about R Markdown in an earlier module, but as a quick review, a single hashtag will result in a level 1 heading, and a double hashtag will result in a level 2 heading. Asterisks around a comment will italicize it, and double asterisks will bold it. To enter an R code chunk, click on the Enter Code icon. A shortcut for doing that is to press Ctrl, Alt, and I. Also, to enter a website, put the name of the website in brackets, followed by the URL in parentheses. I'm going to start by putting the information about the study, including each question, and also label this with a Level 2 heading. Next, I'll include a link to the data. The next thing I will do is put in a section for the dataset names. Here I'm going to insert an R code chunk, and I will call the necessary packages and define the datasets th, mth, and fth. Now, let's address the first question. I'll put the question in a Level 2 heading, followed by the appropriate R code and commentary. How about we knit the document to see how things are looking? It's a good idea to knit your document from time to time, because it's a good opportunity to correct any formatting that may not look right or to organize your document differently. And so now you've seen the process here for question number 1. I'm just going to do the same thing for the remaining questions, setting the question as a Level 2 heading, putting R code into R chunks, and formatting commentary as necessary. After making all of these changes, I'll take a final look at the overall document. I think it looks pretty organized, easy to follow, and it answers all of the posed questions. Now, when you put together a document like this, keep your reader in mind. Be sure to include all necessary information and to organize it in such a way that it can be followed. Appropriate headers and comments can make all of the difference. Okay, so that's it for this lesson. Best of luck as you move forward with the quiz and the first project.